Assalamu alaikum students. So today we will be doing the questions of the second variant of October number 2025 MCQs. Question number 21. Phosphorus is an no, we will do from question number 20. Yeah. Question number 20. Which method is used to prepare a pure dry sample of lead to chloride? So we have to recall the different methods we studied about the preparation of salts. Here, lead to chloride is basically an insoluble salt. This is an insoluble salt. So being an insoluble salt, we would refer to the method related to insoluble salt formation. We remember that first of all, what kind of the reactant will be there to react with each other? We are provided with a lead to nitrate reacting with a hydrochloric acid, and in the C and D option we have lead to hydroxide reacting with a sodium chloride. So basically there is always a reaction between an acid with the compound. There is never a kind of a reaction of a base of the base with the salt or a metal. They can only a reaction of base with an acid, but not a reaction of a base with with the salt. Base plus metal could be the method to give the required salt. It could be a reaction of base with acid. So never a base reaction with a salt. That is not possible. So this is a salt and the other one is a base. So it cannot be this kind of combination. That's why both the option C and D will be considered incorrect. So we are left with options A and B. Now in options A and B, we look at the other steps required for salt formation. So after the reaction is done, we do require filtration because filtration will separate the solid part from the liquid part. Solid is this salt here and liquid is the soluble solution. So after filtration, A says crystallize and dry the filtrate and B says wash and dry the residue. So if we remember, crystallization was done to convert the soluble salt into the solid part. Soluble salt was converted into solid form. And solid is a salt, the required salt. But in our current scenario, the salt that is produced is lead chloride, which is already an insoluble salt. So we do not require the step of the crystallization. Crystallization is not required here to form the solid, or maybe you can call insoluble salt. So the other step is, however, the right step or the correct step is the wash and dry the residue. This residue is basically the insoluble salt. This is the insoluble salt. So residue is to be washed and dried. So in this way, the correct option becomes the B option. Then question number 21. Phosphorus is an element in group 5 of the periodic table. It burns in air to form an oxide that dissolves in water to form a solution of pH 1. Which row describes the oxide of the phosphorus? So here, if phosphorus is forming an oxide, which when dissolved in water produces the acidic solution, we remember pH value 1 indicates a very strong acidic medium or a nature or a solution, strongly acidic nature. So it it shows that phosphorus is definitely present on the right side of the periodic table because phosphorus will be considered to be a non-metal. It is considered to be a non-metal. So being a non-metal, it is forming the acidic compound. The acid, it is basically an acid. When it is dissolved, it forms an acid. And when it reacts with the oxide, it is called acidic oxide. So acidic oxide dissolved in water produces acid. So in a simple way, we can tell that phosphorus is the non-met is basically a non-metal. From first column, C and D are the correct options. It is a non-metal oxide, and from the second column we say it is non-metal oxide. Non-metal oxide. This one, and from the third column, it is not the basic oxide, rather it is the acidic oxide. So acidic oxide is mentioned in option C and option A. So in this way, we have all the three takes in the option C. So option C is a correct option. I hope it's clear to everyone. So option C. Then question number 22. The equation shows the reaction between aqueous hydrogen bromide and aqueous ammonia. Which statement describes the role of the aqueous hydrogen bromide? Now options provided are catalyst, reducing agent, proton acceptor, proton donor. If we look at the option A, which is about a catalyst is that species which is used and then reproduced, used and reproduced or reformed. That substance which is used in one step but that is reformed in the second step is the catalyst, because we remember catalyst is that substance which is not chemically utilized. It is not chemically utilized. It is still remains unchanged. Catalyst is something which is unchanged. So if it is unchanged, it should be there all the time. But in the given equation, there is no such thing like that. We do not see HBr is again produced in the product side. Rather, it is broken. Somehow it is broken. It is no more HBr on the right side. So that's why A is not the right option. B says it is a reducing agent. So to validate this answer, you need to assign the oxidation numbers on all the elements. So I will do one by one for all the elements. In the HBr, we remember bromine is a non-metal, so it will have a -1 charge on it. It is belonging to group number 7. So hydrogen will have +1. In the ammonia, hydrogen is non-metal, nitrogen is also a non-metal, but nitrogen is an element of the group number 5. So those which are present on the right side of the periodic table, they are strong. They are more or strong non-metals as compared to hydrogen. So it is more strongly non-metal. So that's why the oxidation number on nitrogen will be -3 and oxidation number of hydrogen will be +1. Hydrogen is less non-metal, less strongly non-metal as compared to nitrogen. So +1 for one atom of hydrogen, and you multiply with 3 to make it +3. Now in ammonium ion, NH4 plus, nitrogen is again -3, and hydrogen, for one hydrogen it is +1. For at 4 atoms it will be +4, and bromide is -1 again, because just one atom here. So you see there is not a difference in the oxidation number of any of the elements. neither hydrogen nor bromine or nitrogen. None of these three elements is showing any kind of the change in the oxidation number. That's why we cannot say it is a reducing agent. We do not say HBr is a reducing agent. So that's why B is eliminated. Then option C, HBr is a proton acceptor. So how do we check it? Whether it's whether it's a proton acceptor, we just compare it from the right side. This is HBr, and on the right side it becomes Br only. That shows HBr has been converted into just Br negative. That means there is a loss of the hydrogen ion. H plus has been lost from the HBr, and we now H plus is called proton. That's the second name of H plus, hydrogen ion, proton or hydrogen ion. Both names are used occasionally. So we say HBr has lost the proton. So it is not acceptor, it is donator or donor, whatever word you use. HBr is proton donor because when we compare it with the bromide, there is no more hydrogen bonded with the bromine. That's why we can clearly say it has lost the proton. And by lost proton, we mean HBr has donated the proton. It is a donor. So that's why C is not the correct option. And the correct option becomes the D option. It's a proton donor. HBr is the proton donor. I hope it's clear to everyone. Then question number 23. Which statement about the elements in group 1 is correct? Hydrogen is produced when group 1 elements react with the water. Okay, so for the time being, I will consider this statement as the correct option because what we learned in the literature that metals reaction with water produces two products. One is the salt and the other one is hydrogen gas, H2. And this is what we write here. Hydrogen is produced, H2 is produced. So for the time being, I will consider this statement correct because I will need to check the other statements. But one thing that I need to also elaborate here, they have said group 1 elements. They have said group 1 elements. And we remember in the periodic table, if you look at the periodic table, the first element of the group 1 is which element? Can anyone tell me? Which is the first element in the group 1? Shazin, can you tell me? What's the name of the first element of the group 1?
Sorry, is it lithium?
Okay. Ishal, what do you say?
Hydrogen.
Okay, and Bilal?
Can you repeat the question?
Which is the first element in the group 1?
Sodium.
So there are three different answers, and the correct answer is hydrogen. Ishal, you are correct. Hydrogen is the first element. Students, mind it. In the picture of the periodic table, whenever you see the periodic table, it's also there in the last page of this paper. So right over here, just look at the elements of the group 1. They have deliberately represented hydrogen on mid of the periodic table, but you should remember this belongs to group 1. Why? Because atomic number 1 should start from here, and atomic number 2 is over here. This is atomic number 2. So this is the first element of the group 1. So it's not lithium, it's neither sodium. Bilal, I'm very much astonished to hear your answer. Even move down to the third period. What's the matter? So it is hydrogen H. Okay, and then what do you know about hydrogen? Hydrogen is a non-metal. It's a non-metal. It's not a metal. It's non-metal. But whereas all the rest of the elements below group 1, they are all metals. We do not consider francium to be very much metal because it's basically a radioactive element. But anyways, rest of the elements, mostly they are all metals. Lithium, sodium, potassium, radium, cesium. So what we said that about the reaction of the group 1 elements, or I would say, what we say about the reaction of the metals with water, it produces salt and hydrogen gas. But how can we generalize this thing? When it says group 1 element, it would also include the H. H is also present in group 1, but hydrogen does not give hydrogen gas again by reaction with the water. There is no such thing like that. H2 reaction with the H2O will produce salt plus hydrogen gas. No, there is no kind of a reaction between them. So there is a kind of a mistake that I would say by the examiner. They have not properly structured the question here. They should have written the words like hydrogen is produced when group 1 metals react with the water. I would say this should be the correct word, not the elements, because hydrogen is also present in group 1. So there is a kind of slight mistake in these words. I hope you're all clear about this concept. So for the time being, I'm considering A as a correct option. So I will move on to the correct option B. Ions of group 1 elements have a -1 charge. So that is totally incorrect. Again, I would say some more part over here. Group 1 elements, what you learned that group 1 elements are mostly metals. So mostly metals have +1 charge. Whereas hydrogen, which is a unique case here in group 1, it can show both +1 charge as well as -1 charge. It has both charges. -1 charge is always there whenever hydrogen, being a non-metal, it is bonded with a metal, like for example NaH. So it's an ionic compound. So in this case, sodium will have +1 charge and hydrogen will have -1 charge. So hydrogen has a different scenario. It can also contain -1 charge, but it doesn't mean that all the metals, it doesn't mean that all the elements have -1 charge. So that's why B is incorrect. Then C, sodium is more reactive than potassium. So we remember from our yesterday's class about the reactivity series of the metals. As we move down the group, the reactivity of the group 1 metals increases. It increases, reactivity increases, and the position of the sodium versus potassium is hydrogen, then lithium, then sodium, and then potassium. So potassium is more reactive as compared to sodium. So this makes C option incorrect. Then D, solid sodium is a poor conductor, electrical conductor. Okay, so sodium is, metal, and metals are all good conductor of electricity because of the presence of the delocalized electrons in them. You can also call them delocalized electron, or you call them mobile electrons, or you can also call them free electrons, freely moving, more precisely, freely moving electrons. So because of this reason, all the metals are good conductor of electricity. So that's why D is also incorrect. So we now come back to the A option, which because of poorly structured question, it is still correct, considered to be correct if you consider most of the elements in group 1 are metals. So A is a correct option. Then 24. Which row describes the color and the state of the iodine at room temperature and pressure? So iodine, when it's symbolized with I, and if you have to recall the position of the group 7, and this is an element of group 7. So how do you place the elements in a sequence form, in an orderly form? First of all, you have the fluorine, then chlorine, then bromine, and then iodine. So we remember fluorine is normally at room temperature and pressure, it is gas. Chlorine is a gas. Bromine is a liquid. And iodine is a solid. So these are the normal physical states. So iodine is a solid substance at room temperature. And about the color, so there were three different colors for iodine. When it is in the solid form, it is gray black. In solid form, gray black. In liquid form, it is brown. And in gaseous state, it is purple. There are three different colors. By liquid, we mean the aqueous solution, mind it. There is no physical state of liquid existed by the iodine. Iodine does not show the liquid or molten state. There is no molten state of the iodine because it shows the phenomena of a conversion from solid to liquid, which is called sublimation. It shows sublimation process, conversion from solid to a gas directly. So it does not have liquid state. By liquid, we mean the aqueous form, which means when I2 is dissolved in water, H2O. And for this reason, we symbolize it I2 with a bracket and AQ in it. This is called aqueous form of the water or iodine water. So in iodine, it is brown in color. So in this way, B is the correct option. Then question 25, part of the periodic table is shown which element is an inert gas. So if you remember, inert gas also means a noble gas. And by noble gas, we mean the elements of the group 8. So this is group 8. And the other name is group 0. There's another name, group 18. And there's another name, noble gases. And there's another name, inert gases. All these names belong to the same column. 8, 0, 18, noble gas, inert gas. All of them are representing this last column, this last group of the periodic table. And noble metals, where are the noble metals? Because noble metals are present over here, copper, silver, and gold over here. This one. This one is copper, this is silver, and this one is gold. So these are noble metals. By noble, we mean inert. They are inert metals. So correct option of this question is C. Then question number 26. 4 different metals. 4 different metals are separately added to water. The oxide of each metal is separately heated with the carbon. The results are shown. What is the order reactivity of the 4 metals? Least reactive first. So just by looking at the table, you can easily infer the reactivity, especially for the most reactive and the least reactive. These two metals can easily be identified. Most reactive metal will be the one which will show the rapid fizzing. And if you remember, which gas is being produced, can anyone tell me? Which gas is being produced over here? Why are we having fizzing? Which gas is the identity over here? Can anyone tell me? Yes, please, anyone. For which gas we will say fizzing here? No answer from anyone. Shazin?
Can you repeat the question, sir?
Sir, can it be carbon dioxide gas?
Okay, Shadin, I said which gas will be produced over here when we are saying the reaction of a metal with water. Which gas will be produced here?
I'm not sure.
Did I not? Okay, leave it. If you don't. And Bilal, what about you? Yes, Bilal. Bilal, are you there? Okay, students, I did just give the answer a few minutes ago, if you remember. What did I say over here? Direction of a metal, with a water. What did I say over here? Ishal, why did you forgotten? Metal
Sir,
reaction with water.
it mentioned carbon in the question, so I assumed that.
So hydrogen gas, it is produced here. Shazin, I think you are weak in these topics, so you have to reinforce these topics from the literature so that you could be able to answer correctly. So metal with water produces the hydrogen gas. So bubbles and fizzing, they are indicating the magnitude of the reaction or intensity of the reaction. So if it is fizzing reaction, it means there will be a violent or very fast reaction here. And few bubbles would mean it is moderately reactive, not very fast reaction, just a moderately fast reaction. So violent reaction would mean that metal R is the strongly reactive metal. So reactivity of the R is highest, and we have to identify the reactivity order with the least reactive first. So it means R will be at the extreme right side. So in both option A and B, we have R at the extreme right side. Now, we have to also identify the least reactive metal here. So the least reactive metal will be the one which is showing no reaction. Q. Q is the least reactive. So both option A and B have Q at the left side, extreme left. But there is a difference of the other two elements, metals, T and S. So how would we arrange them? Over here, we can see there is a difference of T and S on the basis of their reaction with the carbon. Okay, so if I say this is metal oxide, M is any metal, it could be S, it could be T, and it is reacting with a carbon. This is what it says, metal oxide with carbon. So as a result of this, there will be the formation of the, obviously, an oxide of the carbon. There will be oxide of the carbon that could be either carbon dioxide or it could be carbon monoxide, whatsoever. I do not know which one is there. And as a result, metal will be separated. So it says, how would you tell which metal is more reactive? This metal is more reactive or this metal is more reactive, in which metal oxide when reacting with the carbon does not give any product. So no product. Because in one case, we have the formation of the T and S. In one case, there is no reaction, which means no product. And in the other case, there is any product form. They are just saying gray solid. I do not know which metal that would be, but that says there is a product. So there is a product form in T and there is no product form in S. So we just have to look at here that if carbon if carbon is more reactive than metal, then only in that scenario it will form the product. But if the metal is more reactive than carbon, then it will not leave its oxygen. It will not let the oxygen separated from the metal. So in the case metal, if the metal is more reactive than carbon, so it will not let the oxygen out of the compound to react with the carbon. So we can say between T and S, if T is forming a gray solid form, which means the metal has lost the oxygen. The metal has lost the in a sense oxygen, and in case of the S, a few bubbles, no reaction, which means the metal was already uh, higher in reactivity as compared to the carbon. So according to this, A is the correct option, in which T is more according to the reactivity. S is more reactive. Why S is more reactive? Because we can see S is giving no reaction, which means the metal is not letting the oxide out from the compound of the metal oxide. It is already more reactive. That's why S is more reactive than T. T is forming any other product, which we do not know which metal is that, which we do not know which product is that. So in this way, A is the correct option. I hope it's clear to everyone. So when metal is more reactive than C, it is basically S metal, in which case no product is formed, no reaction is there. Then question number 27. An iron is fully covered with zinc. To prevent it from rusting, which rule describes this method of protection and explains why zinc is used to protect the iron nail? So the method of protections, if we cover the iron with zinc, like inside we have iron, and on this we have the coating of the zinc coating. This is what they are saying. So what kind of reaction is there? Why, if we are allowing zinc to be coated in the iron, we are basically protecting the iron. We are protecting iron. So in this case, it is basically the sacrificial protection of the iron, and at the same time we are putting a coating of the zinc on the iron. So when there is coating, there is basically a barrier formed between the two metals. Zinc and iron will there to have a barrier between them, so it is also called barrier method. We did not actually study this in detail like this, but you can have this knowledge from the first page of the metals chapter. When we learn this chapter of metals, you just go through all these lines, all these words. This is basically the specifications or the outlines or the learning outcomes which we have to cover for the exam. And in this case, you just move on to the prevention of the metals, corrosion of the metals, and there. Number 4, describe the use of zinc in galvanizing as an example of a barrier method and sacrificial protection. So there is a clear indication that the zinc coating is used in these two methods. One is the galvanizing, which is a subtopic of the barrier method, and sacrificial protection. So galvanizing, barrier method, sacrificial protection, they all mean the same thing for zinc used in the protection. When you use zinc, it is also called galvanizing and barrier method and sacrificial protection. So mind it, always go through these lines which I have already included in the start of every chapter. All the notes which I have provided you, all of them have these pages at the start, and then the rest of the literature starts. So Shazin, if you also require these notes, you can let me know. You can message me if you require these notes.
Okay, sir.
So the next is yes, barrier method sacrificial protection, fine. And why we are using zinc? Because zinc is considerably more reactive. Because if zinc is more reactive, it will be rusted as compared to the iron. Zinc should be more reactive, only then it can protect the iron. If it is less reactive than iron, then definitely iron will be oxidized and not the zinc. So that's why we use zinc. So according to this is a correct option. Then question number 28, iron is extracted. Iron is extracted from the hematite in the blast furnace. Which reaction increases the temperature in the blast furnace to over 1500 degrees centigrade? So we need to locate the reaction which would produce a temperature that could reach up to 1500 degree centigrade. So for this purpose, I will take you to the notes and we'll find that reaction. It is in the iron extraction topic in the chapter of metals. Okay, so extraction of iron from its iron ore, and here the temperature ranges. There were temperature ranges over here, this one. Although there were 3 different diagrams, but we have to use that particular diagram which is more related. In this diagram, you cannot properly see where the temperature mentioned, and also here it is somewhere over here, but even then it is not 1500 degrees centigrade. But if you look at this diagram, it is clearly indicating the 1500 degrees centigrade is mentioned over here. This 1500 degrees centigrade, and this is when carbon reacts with the oxygen to make carbon dioxide. That belongs to 1500 degrees centigrade. So that's why I included everything, all the literature in my notes, so that nothing should be skipped. No point should be left behind. That's why I made very comprehensive notes of all the chapters, and which you have to learn very carefully. Learn them by practicing. So coming back to here. So the reaction that produces 1500 degrees centigrade is carbon reaction with the oxygen to make the carbon dioxide. It should not be carbon monoxide. Question number 29. Aluminium is extracted by the electrolysis of purified bauxite. Which row shows the half equation at the electrodes and explain why one of the electrodes has to be replaced regularly? So reaction at the anode and cathode. We remember the reaction at cathode. This is what we learned in the yesterday class. We also learned the same question. We had the cathode reaction as the formation of the aluminum metal. So from here, option A is the correct option, and option B. These two are the correct equation. I can recall you from the topic of the aluminum. So here it is represented direction of the cathode. This is the direction of the cathode, which is formation of the metal by the gain of electron. And the anode direction is the oxide ion getting oxidized into oxygen gas. So there is oxidation of oxide ion at anode to form the oxygen gas. So at anode, oxide ion converting to oxygen gas. So both A and B are correct. And why we require the anode to be replaced? We remember there was a reaction of the anode with the oxygen. Anode used to react with the oxygen gas. By this oxygen which is formed at anode, it reacts with the oxygen to form carbon dioxide, which means anode was basically the it was made of the graphite material, graphite, which is basically a form of the carbon that is used for construction of anode. So that's why carbon dioxide used to form, and that reaction will gradually decrease or lessen the amount of the graphite rod. The graphite will be constantly used up during the reaction. So what it says, cathode replaces as it gets coated with aluminum? No. Anode replaced as it burns away in oxygen. So that is the correct reason. Anode is burned away because it is burning process. Anode reaction with oxygen, this is burning or combustion. So that's the correct option. So that's why B is the correct answer. So this was the related questions. All the other questions, they are not related to the topic which we are currently covering. So we will attempt the remaining parts of this paper in the next 4th chapter's revision. So that's all. If you have any question, please let me know. Otherwise, take care and Allah Hafiz everyone.